Before we dive into today's main stories, we have a quick update on a mission we've been following closely. Isar Aerospace's second Spectrum rocket launch, onward and upward.
And unfortunately, it's not the news we were hoping for. On the evening of March 25th, the Spectrum rocket was sitting on the pad at Andøya spaceport in Norway. Countdown running, world watching, and the flight aborted at T-3 seconds. 3 seconds from ignition.
The launch window closed without a second attempt, and as of right now, no new launch date has been announced. The cause of the abort hasn't been made public yet either. This was already a mission that had been delayed multiple times by bad weather, and now this.
For context, Spectrum's first flight last March ended about 30 seconds after liftoff when a vent valve opened unexpectedly and the rocket came down into the sea near the pad. Isar fixed the issue, passed static fire tests, loaded up 5 CubeSats and a science payload, and went back to the pad. And they got to T-3 seconds.
Which, as painful as it is, does suggest the vehicle is healthy and the abort system is doing its job. We'll keep following this one. For now, Isar's European dream of reaching orbit is still waiting.
And we're going to stay in the world of difficult space news for our first main story today, because Canada has just canceled its first ever Moon Rover mission.
The water-seeking lunar rover project, which the Canadian Space Agency first announced back in 2021, has officially been terminated in Canada's spending plan for 2026 to 2027. It was a mission designed to explore the moon's south pole, hunt for water ice, and probe the geology of our closest neighbor in space.
And it came remarkably close to being real. The rover was being built by Ontario company Isar Aerospace under a $43 million Canadian contract. It was at Phase C of development, approaching its critical design review later this year. That's not a concept on a whiteboard. That's hardware being built in a lab.
The mission lead scientist, Gordon Osinski from Western University, known in a lunar community simply as Oz, told Space.com that his team received the news back in February and spent a month trying to fight the cancellation. He said, and I love this quote, "It's hopefully not a lost cause."
The rover was expected to ride to the moon on Firefly Aerospace's 2029 commercial Lunar Payload Services mission, landing on the rim of Haworth Crater at the South Pole. 6 instruments, 20 years of Canadian rover expertise wrapped into a 35-kilogram vehicle. Gone.
Canada says the knowledge and expertise built up through the program can be repurposed. There's a planned Canadian lunar utility rover in the pipeline, essentially a cargo vehicle to support future Artemis astronaut missions no earlier than 2033. 3 companies are already doing preparatory studies for that vehicle.
But there's a bigger picture here too. This news landed the same week NASA announced it was pausing the Gateway lunar space station. And Gateway was supposed to be maintained by Canada's Canadarm3. That's a lot of uncertainty hitting the Canadian space program all at once. MDA Space, which makes Canadarm3, has said its contract with the Canadian Space Agency is continuing, and the arm is still in the design phase, so there's flexibility to adapt. But still.
And all of this is unfolding less than a week before the Artemis II launch, which includes Canadian astronaut Jeremy Hansen on the crew. He'll be the first non-American to fly on a moon mission. So Canada is simultaneously about to hit one of its highest ever moments in space exploration, while quietly canceling its lunar rover.
Space is complicated, but we'll raise a glass for Oz and his team. They did remarkable work, and that knowledge doesn't just disappear.
All right, let's switch from the geopolitical and the heartbreaking to the genuinely thrilling, because astronomers have just solved a mystery that has been haunting the field for over 150 years.
The star at the center of all this is called Gamma Cassiopeiae, or Gamma Cass for short. It's actually visible to the naked eye. It forms the central peak of the W shape in the constellation Cassiopeiae. And back in 1866, an Italian astronomer named Angelo Secchi noticed something very strange about it.
Its hydrogen signature, the hydrogen fingerprint that appears in a star's light, was bright, where in stars like our own sun, it normally shows up as a dark line. That was so unusual, it actually created a whole new classification of stars, the so-called B stars. B for the hot blue-white type, and E for the peculiar emission. Gamma Cass was the first of its kind, and it's been mysterious ever since.
Then, in the 1970s, the mystery got bigger. Astronomers discovered Gamma Cass was pumping out incredibly intense X-rays, the kind of X-rays you'd expect from plasma burning at around 150 million degrees. For context, that's about 10 times hotter than the core of our own sun. It's shown 40 times brighter in X-rays than a typical star of its size. Nobody could explain it.
Two competing theories emerged. Either the X-rays were being produced by magnetic interactions between the star and the disk of material spinning around it, or there was a hidden companion star pulling matter from Gamma Cass and heating it to extreme temperatures as it fell in. The problem was, no telescope was precise enough to settle the debate, until now.
Enter XRISM, the X-ray Imaging and Spectroscopy mission, run by Japan's space agency JAXA in collaboration with NASA and ESA. Using its ultra-high precision resolve instrument, the team observed Gamma Cass 3 times in December 2024, February 2025, and June 2025, and tracked how the X-ray signature changed between observations.
And the result was definitive. The X-ray emissions follow the orbital motion of the companion, not the B star itself. The hidden companion is a white dwarf, a dead star, roughly the size of Earth, orbiting Gamma Cass on a 203-day cycle and slowly siphoning material from the larger star. As that material falls onto the white dwarf, it heats to extraordinary temperatures and blazes in X-rays.
Team leader Yael Nazi of the University of Liège called it extremely satisfying to finally have direct evidence after so much effort across so many research groups over so many decades. And this isn't just about one weird star. It confirms a whole class of binary systems that theorists predicted existed but had never been clearly identified. Gamma Cass is now the prototype for the BE plus white dwarf binary family.
A mystery that started in 1866. Finally closed in 2026. That's the kind of scientific patience that makes you feel very small and very odd at the same time.
Here's the question that sounds simple, but turns out to be surprisingly tricky. Why is Neptune tilted?
Neptune has an axial tilt of about 28 degrees, not as extreme as Uranus, which is basically rolling around on its side, but still a significant lean. For decades, the standard explanation was that Neptune must have been hit by something large during the solar system's chaotic early period, knocking it off axis. Big collisions with planetary embryos, that kind of thing.
But new research is proposing a very different culprit, one that's been sitting right there in Neptune's own backyard all the time: Triton.
Triton is Neptune's largest moon, and it's one of the strangest objects in the solar system. Unlike virtually every other large moon, it orbits backwards, in the opposite direction to Neptune's rotation. That alone tells you it wasn't born there. It was captured, probably from the Kuiper Belt, billions of years ago.
And the new research suggests that capture event, and specifically the way Triton's orbit evolved after being captured, may have been enough to tilt Neptune's entire spin axis. The mechanism involves what's called a spin-orbit resonance. As Triton's orbit gradually decayed due to tidal forces and circularized, it passed through a resonance with the fundamental frequency of the solar system, and that resonance torqued Neptune's axis over. The simulations show tilt exceeding 50 degrees in some cases.
So rather than a catastrophic external collision, the tilt could have been an inside job. Neptune's own rebellious moon, slowly nudging its parent planet off kilter over millions of years, just by the gravitational dynamics of its captured backwards orbit.
It's a beautiful piece of celestial mechanics, and it's a reminder of just how much one object can quietly reshape the world around it without anyone noticing over deep time.
Triton has always been my favorite chaotic moon. This just cements it.
Now, this one is a genuine milestone, and one that's had a long road to get here. NASA's Dragonfly mission has officially entered the integration and testing phase.
The rotorcraft lander that will one day fly over the surface of Saturn's moon Titan is being assembled right now.
The work is happening at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, APL, which is leading the mission. And when we say rotorcraft, we mean a full car-sized nuclear-powered drone. Not a prototype, not a model, the actual flight vehicle that is going to launch in 2028 and spend 6 years traveling to Titan.
The early weeks of integration have focused on two critical components. The integrated electronics module, essentially Dragonfly's brain, housing the core avionics, including command, data handling, guidance, and navigation, and the power switching units that control the flow of electricity to all the instruments and systems. Both passed their first power-on tests connected to the spacecraft's wiring system.
Principal investigator Elizabeth Turtle called it, and this is a great line, the birth of our flight system. Because that's really what integration is. All the components that have been designed and tested and refined separately are now coming together as one machine for the first time.
And the rest of the vehicle is taking shape too. The aeroshell and cruise stage are being integrated and tested at Lockheed Martin in Colorado. Wind tunnel testing at NASA Langley has been completed. The foam insulation that will protect Dragonfly from Titan's minus 180 degrees surface temperatures is being tested in a dedicated Titan chamber at APL. The flight radio has been delivered. The science payload is coming together at institutions around the world.
Integration and testing will continue at APL through this year and into early 2027, when system-level testing moves to Lockheed Martin. Then it returns to APL for final environmental testing before heading to Kennedy Space Center in spring 2028 for launch on a SpaceX Falcon Heavy.
And why is Titan worth all of this? Because it is one of the most extraordinary places in the solar system. It has a thick nitrogen atmosphere, lakes and rivers of liquid methane and ethane, complex organic chemistry on its surface, and likely a subsurface ocean of liquid water. It looks, in many ways, like a frozen early Earth, and studying it may help us understand how the chemistry of life got started. Dragonfly is going to fly to dozens of locations across its surface, sampling, imaging, sniffing the atmosphere.
We are literally building the thing right now, and in 2034, it lands on another world. That's extraordinary.
Story 5 takes us to Kazakhstan, and a moment that's been a long time coming for Russia's troubled space program.
Baikonur Cosmodrome is one of the most storied launch sites in history. The place where Sputnik launched, where Yuri Gagarin launched, where the Soviet and then Russian space program wrote some of its most legendary chapters. But last November, one of its launch structures suffered a catastrophic structural collapse. It was a major blow to an already struggling program.
The repairs are now complete. A fresh cargo mission has launched successfully from the same pad that failed, and Russia is back in orbit. On the surface, it looks like a recovery story, and in some ways it is.
But the broader context is hard to ignore. The Russian space program that once put the first human in space, that was neck and neck with the United States in the greatest technological race in history, is now a shadow of what it was. Budget pressures, geopolitical isolation, brain drain, the loss of international partnerships, all of it has compounded over the years into a program that is struggling to find its footing.
The successful launch from Baikonur is genuinely good news for the cosmonauts who depend on cargo resupply and for the engineers who work through the repairs. But it doesn't resolve the deeper questions about where the Russian space program goes from here, or whether it can rebuild its place among the stars.
Space exploration has always been at its most powerful when it's collaborative. And whatever your views on geopolitics, there's something genuinely sad about watching a program with such an extraordinary legacy find itself so diminished. We hope the trajectory turns around.
And we're closing today with something that is a combination of deep history and cutting-edge astronomy. Because NASA's brand new SPHEREx space telescope has just made a striking observation of the remnant of a nova that exploded over 120 years ago.
Nova Persei 1901. On February the 22nd, 1901, astronomers watched a star in the constellation Perseus suddenly blaze to life, becoming one of the brightest objects in the night sky. People all over the world could see it. For a few days, it was dazzling.
Unlike a supernova, which destroys a star, a nova is a thermonuclear explosion on the surface of a white dwarf in a binary system, triggered when it accumulates enough material from a companion. The star survives, but the explosion blasts material out into space at enormous velocity.
SPHEREx, the spectrophotometer for the history of the universe, epoch of reionization, and ICE's Explorer, which is a mouthful even by NASA standards, launched earlier this year and is already delivering science. Pointed at the remnant of Nova Persei, it detected something remarkable, a bipolar molecular hydrogen shell surrounding the nova. Two lobes of hydrogen gas expanding outward from the explosion in opposite directions.
This kind of structure tells astronomers about how the explosion expanded, how it interacted with surrounding material, and what the environment around the nova looked like before it erupted. And detecting molecular hydrogen specifically requires the kind of infrared sensitivity that SPHEREx was built for.
It's a lovely early result for a telescope with enormous ambitions. SPHEREx is designed to survey the entire sky in infrared over its mission, mapping hundreds of millions of galaxies and probing the physics of the early universe. But starting with a 100-year-old nova in our own galactic neighborhood is a pretty charming way to get going.
A star exploded in 1901. A farmer in England looked up and pointed at it, and in 2026, we're building detailed maps of what it left behind. That's science across generations.
That is everything for today's Astronomy Daily. What a lineup! A dramatic abort in Norway, a canceled moon rover, a 150-year mystery cracked open, Neptune's mysterious lean, potentially explained by its own moon, a spacecraft being assembled for a world of methane lakes, a Russian comeback from a crumbles launch pad, and a 100-year-old nova being mapped by a brand new telescope.
There is never a dull day in space. You can find all of today's source links in the show notes. And if you've been enjoying the show, please leave us a review or share the episode. It makes an enormous difference.
We're on X, Instagram, TikTok, Facebook, and Tumblr at Astro Daily Pod. And you can find us at astronomydaily.io for more. Until tomorrow, keep watching the skies.
Clear skies, everyone.